What's going on, everybody? Um, the horrible thing happened or whatever. I kind of recorded a video for you, and pretty much it quit out on me when I was almost done with the video. As you can see, I was doing a whole lot of work on the video all the way up until, and it was good work too, all the way up until here. I was pretty much done. One more problem to go, and it quit out on me. So that just means I gotta start all over. So let me clear all this stuff off. Alright, I'm back, and we were doing radical equations. So I'll do the whole radical equation thing, and it shouldn't take long at all. First off, if you see these two equations, right? They look very, very similar. Look like they're the same equation almost. But actually, one's a radical equation, what we consider a radical equation, and one's a linear equation. If you can't figure out, or if you can't see which one's different or what's the difference between the two, well, notice the one that has the variable inside the radical, one has a variable outside the radical. Since it's outside the radical, that means that this would be a coefficient. But being that we put radicals at the back, that's probably why we have it there. But this right here is our linear equation. With a linear equation, the most you're going to get is one solution. With a radical equation, it depends. This right up here, we'll call this a radical equation. Radical equation. Cool. So in solving these, it kind of shows you what happens. In this problem right here, very, very simple problem. We solve radical equations the same way we solve all equations, right? So say we want to get x by itself. The things that are stopping x from being by itself is this 3 and that square root sign, right? So let's get rid of the 3 first. If we get rid of the 3 first, right? Close that out. What's left now is the square root of x equals 4. Then squaring both sides, x equals 16. So pretty much that's how we do radical equations. So if I give you radical equations, they should not be that bad. All we're doing is isolating the radical, and then we're going to square both sides, all that crap. Here the radical's already isolated. So why don't we square the radical, and we'll end up with 2x minus 1 equals 9, right? Then 2x equals 10, x equals 5. Just like a regular old equation. So it's nothing really to it. If I tried to solve this radical equation right here, I do the same thing. In other words, I want to isolate the radical. If I want to isolate the radical, look at the things that are stopping the radical, stopping the variable from being by itself. This 1 right here and this 2 over here. So let's get rid of both of them. I'll actually do it in a different marker. Adding 1 to both sides. 2 times the cube root of x equals 4. I divide by 2 on both sides. And we'll end up with the cube root of x equals 2. So then, if we're trying to get rid of this cube root, we're going to have to cube on both sides. If we cube on both sides, now you're talking x equals 8. Right? So understand what root you're dealing with and what you have to do because of that. So why don't you, these two problems, I have these problems right here. Why don't you do these two problems on your own, work them out, and then once you're done, compare your answers with what I'm gonna have when you get back, and we'll see from there. But right now, go ahead and pause the video, do the problems that you're doing, or do these problems, and come back and I'll have them done for you. So go ahead and pause the video. Alright, so here's my answers for those two problems. As you can see, all I did on the left side, you guys see where I'm at, As you can see on the left side, just added 3 to both sides and squared the radical. Whatever I do to one side, I got to do the other. End up with t equals 5. Wait, feels like we did this problem already. And on the right side, pretty much added 9 to both sides, then cubed the radical and cubed the 8, x equals 512. So we have some other problems, equations with rational exponents. Now remember, we're just doing the inverse to get rid of what we need to get rid of. For example, 4x to the 2/3 equals 36. We treat it just like any other equation, right? Divide by 4. I'm going to divide by 4 on both sides. Getting the variable all by itself, right? Cross out my 4. I'm going to say now that x to the 2/3 is equal 36 divided by 4. Is that 9? I think it's 9. So now, if you have x to the 2/3 and you're trying to get rid of that 2/3 exponent, what exponent is going to get rid of that 2/3? Why not the reciprocal? So 3/2, right, is the reciprocal of 2/3. And the thing is, when this exponent right here multiplies against this exponent, aren't you going to get 1? Which actually kind of cancels it out. Now, I should say that whatever you do to one, you got to do to the other, right? So with that, I know down here I'm going to end up with x on the left side. But now if I'm doing 9 to the 3/2, that's the same exact thing as 9 to the 1/2 to the 3rd. Took a quiz on this. That was the first question. Well, something like the first question, right? And that's just 3 to the 3rd. So that just means x is going to equal 27, right? Let me do the one down here for you, just so you can see what I'm talking about a little bit more clear. If I have a binomial to an exponent or whatever, we're going through the same exact thing, right? First, let me add 1 on both sides. Alright, I got that out. Add 1 on both sides. So I end up with x plus 2 to the 3/4. And all of that equals 8. Right? So I want to get rid of that exponent. If I get rid of the exponent, then I'm raising that whole thing to the 4/3. Raising it to the 4/3. Right? So that's going to make that exponent 1. I'm just going to be left with x plus 2. Right? So 8 to the 4/3 is just 8 to the 1/3 to the 4th. Remember, we're multiplying exponents. And 8 to the 1/3 is just 2, so you're talking about 2 to the 4th. And 2 to the 4th is just 16, isn't it? So that means that x has to equal 14. After I subtract that 2, of course. So how about this? I just did 2 problems for you, this problem and this problem. What I want you to do is I want you to do these 4. So pause the video, do those 4, and then come back and compare your answers with the ones that I get. So I'm going to pause, you pause, and we come back later. For the 3 problems we just did, let's make sure. For the first one, I got x equals 25. Second one, I got x equals 223. Then I got x equals 6 and x equals 1. So this, obviously you can see this is not a problem either. Now we can actually do problems like this now. What I want you to notice is that nothing's changed. we can do the same exact thing for this problem. Are we recording? Yeah, we're recording. The same thing in solving equations. So for some, notice you have two variables now, but I'm gonna say it again, you do not do any different mutant alien stuff. You do the same exact things that you were doing before. So I can, ultimately I'm trying to isolate the variable so that I could get a solution. The best way that I could be doing this is probably if I add x to both sides. Add x to both sides, then I know that what I'm dealing with now is 3 times the square root of x plus 1 equals x plus 1, since I added x to both sides, right? Then from here, can I divide by 3 on both sides? Yeah, divide by 3 on both sides, right? So now I'm dealing with the square root of x plus 1 equals x plus 1 over 3. In order to get rid of that square root, I'm going to square that side. But understand here, I have to square this whole thing right here. That whole thing needs to be squared. So when that whole thing is squared, understand now that you're left with x plus 1 equals, well actually when I mean the whole thing is squared, I mean the whole thing is squared. So distributing it. In other words, what's in your numerator, this represents one number right here. So you're squaring that one number. You're not squaring x then squaring 1. You're squaring one number. You're squaring x plus 1. So if that's the case, you now have in the numerator x squared plus 2x plus 1 in the denominator, 9. So now it might not look like it's panning out, but what if we multiplied 9 on both sides? If we multiply 9 on both sides, you have 9x plus 9 equals x squared plus 2x plus 1. So why not take the 9x and the 9 over? If I took the 9x and the 9 over, I'm left with 0 over here. Subtracted 2x minus 9x, I'll have x squared minus 7x. Subtract 9 from 1, minus 8. That can be factored. If I factor this, you have an x here, x here. I'm going to use not 2 and 4, but 1 and 8. If I have 1 and 8, signs are different. That goes to the larger, minus sign, plus sign. All of this equals 0. All that means is that either x equals negative 1 or x equals 8. Matter of fact, I'll take these two solutions right here and we're going to find out whether or not these work. They might work, they might not. So ultimately what we have is either x equals 1, I'm sorry, either x equals negative 1 or x equals 8. And remember that the equation that we are checking is 3 times x plus 1 minus x equals 1. We're checking to see if those solutions work in that equation. So we're trying to see what's going to work inside of this equation right here. First check. Let's check negative 1. If we check negative 1, that's 3 times, 3 times, let's see, negative 1 plus 1 minus negative 1 equals 1. Find out. 3 times the square root of 0. That's going to be plus 1 equals 1. This whole thing right here is going to be 0, so you're going to be left with. So it looks like negative 1 worked. That's what we just checked right there. Looks like negative 1 worked. Let's check to see if 8 works. We're going to do, let's see, 3 times the square root of 8 plus 1 minus 8 equals 1. So 3 times the square root of 9 minus 8 equals 1. 3 times 3 minus 8 equals 1. 3 times 3 is 9. Minus 8 does equal 1. Looks like that one works as well. So they both work. And since they both work, our solution set, I'll even write it. Our solution set is negative 1, 8. So all the work I just did for this one, make sure, why don't you try it on this one? Make sure you solve it and check. Solve and check, just to make sure. So why don't you pause the video, do that problem, come back, and we'll see how we all did. So go ahead and pause the video. I'm going to pause too. Oh, I should point out that in a problem like this, since the radical is all by itself, you're going to square the radical. And whatever you do to one side, you got to do the other, right? But just understand, when you're squaring everything at once. So x plus 1 represents one number, just like I said earlier before. So you square both of those. Now you have the information. Go ahead and see if you can solve it. Pause the video and see if you can solve it. Now, as you can see here, when I solved this problem, squared both sides on the left side, x squared plus 2x plus 1 equals 7x plus 15. And then from there said both equals 0. I ended up with x equals 7 or negative 2. I hope you ended up with the same thing. So either x equals negative 2 or 7. When I had to go check them. This is where you're going to see the importance of actually checking your answers. What ends up happening is if I check 7 first, 7 went through, 7 worked because 8 equals square root of 64. However, when I check negative 2, negative 2 came down to be negative 1 equals square root of 1, which is not true. So you can see that this one did not work. So basically we can say that, well actually, sorry, I have a thing about that. I want to make sure that shows what that does. What we say is that negative 2 is, you probably heard me say this before, extraneous. And by extraneous, we just means that negative 2 will not work. So that means that the solution set for this problem right here, if we're talking about the solution set for this problem, is just 7. Not negative 2, because negative 2 doesn't work. So for the most part, I just recreated the work, probably in the same amount of time, whatever. We'll do some more when we get to class, but as of right now, that should be enough to at least start your homework. I'm tired of talking to myself, so I'm gone now.